Now we'll go for the next problem. Find the series of sine and cosines of multiples of x which represents in the interval x lies between minus pi and plus pi, where f of x is given by 0, x lies between minus pi and 0, and pi x by 4, x lies between 0 and pi. Okay, we'll find out the Fourier sine and cosine series, and we are going to deduce this expression. Okay, whether we are able to get this series or not. So there are two things. What is asked? We have to find out the Fourier sine and cosine series. This is first part. Second part is we have to get this expression. Simplifying. N equal to 1, n equal to 2, 3, 4, n equal to 0, 1, 2, 3 goes on. Okay. So now let us see. Let us find out first the Fourier series. Fourier series is given by this, and A0 expression is given by this expression, and an is given by this expression, and bn is given by this expression. So we have to find out now a0, an, bn, and this is the problem. First we will find out a0. a0 equal to 1 divided by 2 pi minus pi to plus pi. Okay, this is not a half range. Okay, this is not half range. So minus pi to plus pi f of x dx. So 1 divided by 2 pi, separating the limits. So limit minus pi to plus pi, separating the limit minus pi to 0, 0 to pi. Instead of f of x, you have to substitute 0. Instead of f of x, you have to substitute pi x by 4. Pi x by 4. So we have now, instead of, so f of x equal to 0 implies that this becomes 0. Second term will be 0 to pi. Instead of f of x, you have to substitute pi x by 4 dx. So we have 1 divided by 2 pi, pi by 4 out. So x integrating, that will give you x squared by 2. Substitute the upper limit, that will give you pi squared, and we have this pi and this pi will go off. We have 2 4s are 8, 8 2s are 16, so pi squared by 16. Already we have seen this problem earlier. Okay, only thing is we have not applied this. Okay, we have seen this problem earlier. So we will find out now an. An is given as 1 by pi minus pi to plus pi f of x cos nx dx. Separating the limit, we can have the separate terms. Minus pi to 0, this is one term. 0 to pi is the another term. Okay, so this term becomes 0 because f of x equal to 0 in this limit. And what about f of x here? Your f of x will be pi x by 4. So your f of x equal to pi by 4. So we have 1 by 4 x cos nx dx using Bernoulli's formula. Okay, so u v dx equal to Bernoulli's formula is given by this, and of course u equal to x. You will differentiate with respect to x, that will give you 1, and v equals cos nx, and your v1 equal to integrating v, that will give you v dx cos nx dx, which is equal to sin nx by n, and v2 is integrating v1 dx, so that will give you sin nx by n dx, which is equal to 1 by n pulled out. So sin nx on integration, that will give minus cos nx by n, so that is simplified as this term. So substituting in Bernoulli's formula, we have 1 by 4 x, so uv, so u is x, v is sin nx by n, minus cos nx by n square, 0 to pi. As we discussed earlier, this becomes 0 for the upper limit and lower limit, because sin pi is 0, sin 0 is 0. So this one will go off. Only this term alone exists, minus plus, so this becomes plus. Substituting the upper limit will give you this, substituting the lower limit will give you this. Right? Cos 0 is 1, and cos n pi is given by this. Instead of n cos n pi, you can write this one. So your an is given by this. What would be bn? Bn, as we discussed earlier, this is an assignment. So you will get answer as minus 1 to the power n pi divided by 4n for bn. So now substituting the Fourier coefficients for a0, an, bn in Fourier series, we will have this term, and plus into minus will give you minus term. Okay, up to this f of x no problem at all. Okay, so f of x is given by this. Now we will have to substitute now n equals 1, 2, 3, 4 goes on, because as per the problem what is asked, this is asked. Okay, this we will have to get with this series. So now First we will write the constant as it is, pi squared by 16 as it is. First we will substitute 1. Okay, instead of n you are going to substitute 1. So this becomes cos 1x, cos x. This becomes sin x, sin 1x, so sin x. Okay, what about here? n equals 1. So minus 1 to the power 1 minus 1. Is it okay? Minus 1 minus 1 minus 2. Minus 2 divided by 4 minus 1 by 2. So minus 1 by 2. Is it okay? And here minus 1 to the power 1. So this will be minus 1. Minus 1 multiplied by minus plus. So plus. This pi is here. Here 4 is here. N equal to 1. So n equal to 1. Sin 1x. Similarly, we will go for n equals 2. So this becomes cos 2x. Correct? Cos 2x. What of this term? Minus 1 squared. Minus 1 squared. What is minus 1 squared? Plus 1. 1 minus 1, 0. So this term will get cancelled. This term will vanish. Okay. So there is no cos 2x term. See here. There is no cos 2x term. What is sin 2x? This term becomes minus 1 squared. This becomes plus 1. So plus 1. This minus here. Okay. This is 4. 4 multiplied by 2. See 4 multiplied by 2. Sin 2x. Similarly, you can calculate for other terms. Is it okay? So now we have expanded the Fourier series in terms of n equals 1, 2, 3 goes on. Okay. Now substitute x equal to pi here. So substitute x equal to pi here. So this becomes, instead of f of x, you have to substitute f of pi. Okay. So this becomes pi squared by 16, the first term. Pi squared by 16. Cos pi minus 1 minus plus, this becomes, so this becomes pi by 2. Okay, cos pi is minus, see minus 1, this becomes 1 by 2. First term becomes 1 by 2. I repeat, see here, cos pi is minus 1, already one minus is there, so this becomes plus 1 by 2. So I have written, see, plus 1 by 2. Here it is 1 by 2. 1 by 2 I have pulled out for every term. For the next term also this becomes sin, you have to substitute sin pi is 0. You have to only go here. Cos pi alone exists. Okay, cos pi alone exists. For the next term that will give you this term. Okay, this term. Sin pi is 0. Cos term alone exists because cos pi equal to minus 1. Okay, cos 2 pi. So similarly, we can go for the next term. I have pulled 1 by 2 out. So this becomes exactly like this. Now we know f of pi equal to f of minus pi to plus pi. The limits as it is given. Because this is even function, I can write 1 by 2 times. So 1 by 2 times f of minus pi to 0 plus f of pi minus 0. So that will give me 1 by 2 pi. So pi x by 2, x equal to pi. So this becomes pi square, x equal to pi. So in this limit according to the problem, see, according to the problem, in this limit, according to the problem, this is 1 is 4 pi. According to the problem, this is pi x by 4. In this limit, 0. See here. So in this limit, this is 0. In this limit, according to the problem, this is pi x by 4. Instead of x, you have to substitute pi. So this becomes pi. So pi squared by 4. 4 2 are 8. So pi squared by 8. So f of pi becomes pi squared by 8. So left hand side becomes pi squared by 8. Right hand side is pi squared by 16 plus 1 by 2. 1 plus 1 divided by 3 squared plus 1 divided by pi squared goes on. I can pull this term to this side. Okay, this term alone. So this term becomes pi squared 1 by 8 minus 1 by 16. I can take the LCM. So this becomes 2 minus 1 divided by 16. 2 minus 1 is 1. So 1 divided by 16. So pi squared by 16, which is equal to right hand side 1 by 2. Okay, these 2 and 16 will get cancelled. This becomes pi squared by 8. So which is equal to 1 plus 1 by 3 square plus 1 by 6. This is the required answer. So look at the problem. This is the required answer. Pi squared by 8, which is equal to 1 plus 1 by 3 square plus 1 by pi square. Goes on. Okay. Now we'll go for the last problem. Find the Fourier cosine series f of x equals pi minus x in the interval x lies between 0 and pi. So we are going to have only Fourier cosine series. We are going to calculate the Fourier cosine series. So f of x equal to 1 by pi. This is where f of x equal to Fourier cosine series. Okay. Fourier cosine series. So is given by this. This is total Fourier series. Fourier cosine series is given by this, where a0 is given by this, an is given by this. This is where total. This is where a0, this is where an, correct? This is where a0, this is where an. Okay. So Fourier cosine series asked. So a0 is given by this, an is given by this expression. So first we will go for a0. A0 equal to 2 divided by pi, 0 to pi. Pi minus f of x is given as pi minus, according to the problem, pi minus x. So instead of f of x, you have to substitute pi minus x dx. I can separate. So 2 divided by pi, 0 to pi, pi dx, minus 2 divided by pi, 0 to pi, x dx, correct? I can pull pi out. Pi is a constant. I can pull pi out. This pi and this pi will get cancelled. So we have 2, instead of dx integration, that will give you x 0 to pi. So that will give me 2 pi. And here integration, that will give you x squared by 2. Substituting the upper limit, that will give you pi squared by 2. So 1 pi and 1 pi will get cancelled. We have now this 2 will get cancelled. We have pi. So 2 pi minus pi will give you pi. So a0 equal to pi. So we have found out now a0. We have found out a0. We have to find out now an. An equal to 2 divided by pi, 0 to pi, f of x cos nx dx. F of x is given by pi minus x. So you have pi minus x cos nx dx. Okay, pi minus x cos nx dx. So this can be written in terms of Bernoulli's formula, which we have used. So that is for assignment. I have written straight away. I have written the answer. Okay, Bernoulli's formula you can use. So pi minus x sin nx by n, 0 to pi. So this is your uv dx equal to u dash v1 minus u double dash v2. Okay, that's the formula, Bernoulli's formula, where u is differentiation and v is the integration. So you have pi minus x sin nx 0 to pi. You have minus of minus 1 cos nx by n square 0 to pi. So substituting the upper limit will give you 0. Substituting lower limit also will give you 0. Sin pi is 0. Sin 0 is 0. You have to substitute upper limit and lower limit. So both the limits, this becomes 0. Okay. Now minus plus. Okay, minus plus. So that will give you minus. So minus cos nx by n square 0 to pi. Now substitute the upper limit. So that will give me minus cos n pi. Substitute lower limit will give me cos 0 divided by n square. Cos 0 is 1. So cos 0 is 1 here. So minus cos n pi divided by n square. Now left hand side is an. An is given by this expression. Now n can be either even number or odd number. Okay, n can be either. N is 0, 1, 2, 3, 4. Suppose if it is even. You are even. Even means you have 0, 2, 4, 6 and all. So this becomes cos 0 is 1. So this becomes minus 1. Minus 1 plus 1 becomes 0. So for all the even numbers, an becomes 0. For all the even numbers, an equal to 0. And for all the odd numbers, odd number means you have 1, 3, 5. So you have 1. So cos pi is minus 1. Already one minus is there. Minus plus 1. So this becomes plus 2. Okay, 2 to 4. 4 divided by, here you have, so instead of n you have to substitute 1. Okay, 4 divided by pi n square. Okay, for all odd numbers, this becomes an equal to 4 divided by pi n square. Is it okay? For all the even numbers, this expression becomes 0, and for all the odd numbers, this an expression becomes 4 divided by pi n square. Okay, so this is the expression for your cosine series. I have written for the odd function. So a0 by 2 becomes pi by 2. plus your an. We have found out an. For all the even functions, this becomes 0. And for all the odd functions, this is 4 divided by pi n squared. So 4 divided by pi n squared. Cos nx. Cos nx as it is in the series. F of x in the series. So we have this term pi by 2 plus this is pi by 4. 1 pi by 4 is missing or this is somewhat there's a mistake here. 4 divided by pi n squared cos nx. So cos nx by n squared we have 4 by pi. So there's a mistake here. This becomes 4 divided by pi. So here 4 divided by pi. See as it is 4 divided by pi. So there's a mistake here. This is 4. This is pi. So your f of x equals pi by 2 plus 4 divided by pi. First term becomes cos x. Okay, because n equal to for odd number. N equals 1, 3, 5 and also cos 1x. So cos x. Next term is cos 3x by 3 squared. What about cos 2x? Cos 2x is 0. For all the even number, cos 0 is 0. Cos 0 is 1. According to the problem, we have minus 1 plus 1 and that will become 0. Okay, so cos 0 is 1. So all the odd numbers, this becomes exactly in this series. Okay, so we have come to the last problem. What is asked to find a naught? F of x is given by this expression. H x lies between minus pi and 0 and 0 x lies between 0 and pi according to the problem. According to the figure, you just see minus pi to 0 the value is such. 0 to pi the value is 0. 0 to pi the value is 0. Minus pi to 0 the value is such. C value is such. This is like a square wave. Okay, it's a periodic function. Okay, periodic function. And number of periodic functions combined together, that will give you sine and cosine term. That is nothing but Fourier series. Is it okay? So number of sine and cosine series you have just combined, that will give me this exactly like periodic table. You add all number of infinite sine and cosine series, that will give you exactly periodic signals. This is nothing but your Fourier series. Okay, Fourier series are nothing but periodic terms. You see, this is periodic series of sine and cosine terms, combination of sine and cosine terms. So what is asked? A naught is asked. So a naught equal to 1 by pi minus pi to plus pi f of x dx as it is given in the problem. So you have minus pi to 0, f of x is given as minus pi to f is in the h. So instead of this you have to write minus pi to 0, minus pi to 0, I have written h here, I have written 0 here, 0 to pi. So that's wrong. Okay, this is wrong. Is it okay? So this becomes h dx, this becomes 0. So that's a mistake here. Okay, see here minus pi to 0 f of x equal to h. So you have minus pi to 0 f of x equal to h. So this becomes h dx, this becomes 0. However you will get the answer. Okay, but this is wrong. So h dx. So instead of h dx you can pull out h, you can pull it out. So that will give me x. Substitute the upper limit and lower limit, that will give you h pi divided by pi, and pi will get cancelled. Your a naught equal to h. So in this problem your a naught equal to h. Okay, so we will stop today. We will see in the next class. Okay.